Hey everyone, welcome back for part two of our module on advanced regression and moderator analysis. So just a quick refresher, 1 second. Okay, so in part one of this video, we talked about, did a little bit of cleaning and coding, and then talked about how to run what's called a main effects model, which is just a regular regression model, before you've actually interacted your predictor of interest and your moderator. And then we talked about a continuous variable by continuous variable moderation model, where we have a continuous IV, in this case, the amount of video games played, and a continuous moderator, which is this callous personality score that we have. And we found a significant moderation, and then we plotted it. We tried to interpret it statistically. We found out that's pretty tough, and then we looked at it visually and found that hopefully a little bit easier. So there are a couple other scenarios I want to demonstrate for you. Sometimes you will have a continuous variable of interest and a dummy or categorical moderator. It actually doesn't have to be a dummy variable. A dummy variable is just the simplest case of this. And so you'll have a categorical moderator like SES, maybe race, ethnicity, gender, and then you'll have a continuous variable that you'll want to test moderation by. This is actually a big part of a big area in quant crit is understanding how models function differently, for example, by race or class. And this is a really important tool for assessing that kind of difference. So it's actually pretty straightforward to do once you kind of get the lay of the land in terms of how moderator analysis works. And so I'm going to show you how to do that. In our case, we have video games as continuous, and callous is also continuous. And so I'm going to artificially create a categorical variable in order to show you what that looks like. You don't actually have to do that if you have, so the general rule is if you have a continuous variable, you should leave it as continuous. So I'm just sort of doing this to kind of create a situation in which we have a categorical variable. So in line 65, I'm just going to make a little histogram, a bar plot using ggplot, and just to try to figure out if I'm going to split, for example, this callous variable up into two scores, how might I do that? So how could I define people who are high callous versus low callous? And one idea is to do what's called a mean or median split and just sort of split the distribution in half. Again, this isn't ideal and you wouldn't do this in real life, but just for our purposes, we're going to split it up into high and low. And the cut point here is about 20. Just looking at this graph, about half the people are below 20 and half the people are above 20. And so another little coding lesson here. This is actually very useful in a lot of moments beyond just this specific one. Sometimes you want to create a variable based on a combination of values in another variable. And a way to do this is what we call conditional coding. So we're going to code something. If a variable is equal to this, then our new variable will take on this value. And if a variable is equal to that, then the new variable will take on an additional value. And so to do this, I'm just going to overwrite our videogames.clean data set. You could create a videogames.clean.2 if you wanted and just keep making new copies. But for our purposes, it should be fine to just create a new copy. So I'm going to call this thing videogames.clean. And I'm going to start with my old videogames.clean. And then our pipe operator, I'm going to mutate. I'm going to make a new variable called high callous. And that is going to be equal to cases when, and the function here is case when. It's a very useful function from the dplyr package. Okay, so when callous is greater than or equal to 20, so when it's high, when people are high callous, I want to code this variable as a 1. And that's what this line means right here. So when callous is greater than or equal to 20, my new variable is going to be equal to 1, and then a comma. And when callous is less than 20, so people are low callous, I want to code that as 0. And then I close my parentheses here. So all this command does is it creates a new variable called high callus, and it's equal to 1 when the original variable is above 20, and it's equal to 0 when it's below 20. So I run that, and notice I now have 5 variables in my clean data set because I've added that new one. I can use the table command here on line 81 just to get a breakdown of my new variable. So I have 250 people who are low callus and 192 people who are high callus. And then I can put some labels on here. And thanks to Erica for tracking this down. This is a nice way of adding labels. It uses a package called XPSS, which is actually uses the SPSS style of coding in R, which is cool because that's a format that we're all pretty familiar with. So what this does is, so you list in this function here, value label, you list your new variable, which is videogames.clean, and then $, high callus. So you're indexing this data frame and this variable. And then you're changing the labels of that variable equal to this. So the number labeling scheme is 1 is equal to high callus and 0 is equal to low callus. So that attaches our new labels. And then we can check that with the structure function. And sure enough, when we look at the structure of this new variable, we now have 0 is low callus and 1 is high callus. So that's great. Okay, so all that to just work with this category. Now a new categorical variable, which is high callus. So now I'm going to have linear model 3. This is my third model I've tested. And that is equal to, again, a linear model. Aggression is the outcome. Video games is my predictor of interest, my IV. High callus is my moderator. And then I have the interaction of video games and high callus. So vid games times high callus. And then my data is still videogames.clean. And the summary function will output the results of that. And sure enough, just like I found in the continuous case, my video games term here, see if I could find my cursor. Here is my interaction term, and it is highly significant. This is a very low p-value, 1.32 times 10 to the negative fifth, so that's 0.00001, and it's positive. So what that means in a categorical case, people who are high callus, which is the value that's shown here, will have a slope of video games that is 0.6 points higher than the folks who are low callus. All right, so there's that again, that idea that if you have that particular personality trait, there is going to be some kind of a positive relationship between video games and aggression. If you don't, that relationship is going to be much smaller or even equal to 0. So that is, again, the same kind of story, just with a different kind of variable. And our friend interplot can help here. So in line 103, I can again do interplot. And linear model 3 is my new model. Variable 1 is still video games. So I'm getting the slope of video games. And variable 2 is high callus. That's my moderator. And when I run this, I get a much simpler representation. I don't get a line because now we have a continuous variable by a dummy variable. And so I essentially get 2 estimates of slope. I get an estimate of the slope for the low callus people, which is this slope estimate right here. And I get an estimate of slope for the high callus people. So for people in the low callus group, the slope of video games is actually slightly negative. It's below 0. And this is essentially a 95% confidence interval. So that contains 0, which basically means that there is not a positive relation or a relation of any kind between video games and aggression for people in this group. But if you're in the high callus group, which is over here, indicated by a 1, you have a positive slope of about 0.6. And it is statistically significant because it doesn't contain 0. So again, same story. High callus group has a strong positive slope on video games. whereas the low callus group does not. All right, so one other scenario I want to share with you. This one is when you have not only a dummy moderator, but you have a dummy X variable. Now, dummy variable just means it takes on the values of 0 and 1, just two categories. You could also have a categorical by categorical moderator. That is the same thing. So this is a case. So how do you do this? Interestingly, a dummy or categorical by categorical moderator model is actually identical and equivalent to a two-way ANOVA. So if you're someone who is comfortable in the ANOVA space and you've run ANOVAs and you get that, that's exactly what a categorical by categorical moderator model is. You have two main effects, which are your two categorical variables, and then you have the interaction of those two categorical variables, which is your interaction term. So believe it or not, even back in 608, we were studying moderation, just in a slightly different way. So in our data, we need to create another categorical variable because we don't have a variable that's high video game versus low video game. So on line 109 here, I just do another bar plot. And it looks like about beyond 21 is a split for people who play a high amount of video games, and 21 and below is people who play a low amount. So, or 22 maybe. It's a bit arbitrary, but that's the values we'll use. And then I create a new variable using the same pattern as before, using the case when function. And I'm going to call this high vid game. And so high vid game is going to be equal to 1 when that original variable is greater than or equal to 22. So everyone who plays at least 22 hours of video games a week is going to be in that category. And everyone who plays less than that is going to get a 0. So that just creates a new variable. And then of course we could do the table function. We can put some labels on this. Again, this is using that same code from the XPSS package. So 1 is equal to high video games, 0 is low. And then we can check the structure of it to confirm that we've coded it properly. All right. So then we can drop this thing in a moderator model. So linear model 4 is equal to a linear model again with regression as the outcome, high video game, high callus, and then the interaction of high video game and high callus, just indicated with a asterisk. You could also put a colon there. And then our data is videogames.clean. So we get our results. And sure enough, again, you focus primarily on the interaction. That's where the story is. So down here, we do have a significant high video game by high callus interaction, and it's equal to 9 points. And what that means, so in this case, when we have two categorical variables, the interpretation is a little bit different because categorical variables represent mean differences between groups. They don't represent slopes. So continuous variables are generally associated with slopes. Categorical variables, those estimates are actually mean differences. So our intercept here, this is actually the predicted aggression score for someone who is 0 on high vid game and 0 on high callus. So this would be the predicted score for someone who is plays video games not that much and is low on the callus score. Okay. If somebody plays low video games but is high callus, they would be predicted to score 8 points higher. If they are high video game, low callus, they'd be predicted to score 2 points lower compared to the intercept. And if they're high on both, they'd be predicted to score 9 points higher. So when you only have categorical variables in your model, you're just comparing means between groups. As a result, our plot also works a little bit differently. So what did we find? We did find a significant moderation here, but it's probably easier to throw this thing in a plot. And so here, I've actually borrowed the code from last week's ANOVA assignment. This is the code for a two-way ANOVA, a box plot. Because again, this is basically an ANOVA analysis. And so we're just borrowing code and looking at it in the same way. So what I've done here, I'm creating a box plot. Here's the geom box plot. I've got labels, Y, X-axis, all that. My new data set. But on the X-axis, I've got high callus. And on the Y-axis, I have aggression. And then I'm splitting those groups up, those callus groups up further according to high video game. And the last thing I've done is I've converted these things to factors ahead of time using the as factor command. And the reason I did this, it's a little bit of a technical reason, but when you use interplot does not play well with factor variables. And so when we created those dummy variables and those categories, it's better just to leave them as numeric and then use interplot. But if we're not going to use interplot, it's actually better that things are factor variables. So it gets a little bit confusing. You kind of have to know which purpose you're using your data set for to figure out what format your variables should be in. But in this case, we want to convert them to factors because ggplot is really good with factors and sort of automatically knows how to handle them. So we run this, and here we get a little bit of a story to tell to explain our interaction model. So we have 4 groups here. Here are our 2 low callus groups, and here are our 2 high callus groups. So notice among the folks who are low callus, right, there's very little difference in aggression between the low video game group and the high video game group. And interestingly, in the low group, low callus, the high video game players actually have slightly lower aggression scores. That's really interesting. That's different than what we would expect, right? Or I guess what our hypothesis might have been. In the high callus group, it's actually opposite. So here is the aggression score for your low video game players. And for your high video game players, it's higher significantly. And so that's the essence of an interaction. It's that kind of discontinuity between the 2 groups. If these had been totally parallel, right, where orange was ahead of blue in both places, we probably wouldn't have a significant interaction. But it's this kind of displacement of the groups that represents the interaction that we're looking for. All right, so we've come to our last little section here. And we're going to talk a little bit about centering. Centering is only a consideration when you are using continuous predictors in your moderation model. So anytime you have a continuous predictor, either an IV or a moderator, you should center beforehand. We didn't do that earlier because I just wanted to kind of cover the basics, but I'm going to show you how to do it now. The reason we do this is it makes the interpretation of the intercept and the interpretation of the model a little more straightforward. So here's how you create a centered version of a variable. All that centering does is it takes a person's score and subtracts the mean. So if I, if I play for video games for 35 hours a week, that sounds like a lot, right? And the mean is 20. My centered video game score is not going to be 35. It's actually going to be 15. So it's 35 minus the mean score, which is 20. If I only play video games for 10 hours a week, my centered score would actually be minus 10 because I'm actually 10 hours below the mean, which is 20. So 10 minus 20 would give me negative 10. So that's actually what we're doing. To do this, we again use the mutate function, and I'm overwriting my videogames.clean data set. And I'm going to create 2 new variables. One, vidgames underscore cent, so that's centered version of video games and centered version of callus. And they are both equal to the original score, which is that, minus the group mean of that same variable. Same thing, original score minus the group mean. So that's going to give me 2 new variables. And when I describe them, Sure enough, down here are my new variables. The means are both 0. And notice the minimum values are now negative because you have values both above and below 0. Okay, so then we can throw these new centered variables into a moderation model. So this is identical as to linear model 2. And all I've done is I've included the centered versions of those variables instead of the regular ones. And the only thing this will change, it won't change your slopes, these things, it won't change your standard errors or your significance. It will change your intercept because the intercept now has some meaning. Before, so note the intercept, of course, is the value of y when all other predictors are equal to 0. But in our case, very few people have a aggression score of 0, or not aggression, video game score of 0. They play for 0 hours, and a callus score of 0. So in other words, that model is not terribly representative of my sample. But by centering, I'm now predicting that model right in the middle of the distribution. And so it's a little more realistic. And so that will change the value of the intercept. It won't change any of the other slopes or standard errors, but it will change the intercept. And then we can visualize this. Again, I've just put in my new variables, which are vidgames cent and callus cent. And the shape of the line is identical. The only difference is the middle of this plot is now 0 instead of 20, because 20 was right around my previous mean, but otherwise it's exactly the same. All right, if you want to go a step further, I also demonstrated how to make a summary table here. Again, using the model summary package. First, you make a list, and in that list, you include all the models you ran, 1, 2, 3, 4, 5. And then you just call model summary on that object, and it will produce a summary document for you. There it is with all the values. And I don't know why it always shows up with the weird gray font, but you can always copy and paste that into Word and change it to black to make it a little bit more clear to see. So there is my summary of all the models I ran and my estimates. All right, so just to recap, this is part 2. Part 2 of this video, we broke down continuous by categorical moderation and categorical by categorical moderation. And we actually found out that that last category, categorical by categorical, is actually just a 2A ANOVA, which is something we've tackled before. Finally, we talked about centering variables and the importance of that and what that looks like in R. So you've picked up hopefully quite a few new tools that you can use, and I hope you find them helpful in your use of regression. Thanks and good luck.